Okay, so this will be the energy equation if you will install or you will add a pump to your system. So always remember that the pump will always add energy or always add head to your system. So in most cases, pump is used to raise water from lower elevation to higher elevation. Okay, so that is the very purpose of a pump. In a more technical term, the use of pump is basically to increase the energy of flow. So because of the pump, the energy of flow will be increased. So para makasaka from point 1, let's say this is your point 1, and then gusto nimo nga moabot sa point 2, and then just by simply using the pressure, dili makasaka siya dito sa ibabaw. So you have to add pump in order to increase the energy of flow para maabot siya dito sa point 2, and then adto na nimo siya i-distribute. Okay? The pump consumes electrical energy, so that is P input, and delivers flow energy P output. So sa kuan, ang imong mahitabo diri sa imong energy equation is that you'll have the energy at point 1 plus the energy added sa imong pump is equals to the energy at point 2 plus the head loss sa point 1 kutob sa point 2. So, diri musaka ang imong energy, musaka, pero tungod kay gibutangan naman po nimo sa jag pump, mas musaka pa na sa dito, and then moubos na pagbalik dire sa imong point 2. Okay, so the energy at point 1, let's say for example, is V1 squared over 2G plus P1 over gamma plus Z1 plus the head added by the pump is equals to the energy at point 2, V2 squared over 2G plus P2 over gamma plus Z2 plus the head loss from point 1 kutob sa point 2. So the output power of pump is equals to Q gamma times the head added, wherein Q is the discharge, gamma is the density or the mass, the weight density of the fluid, and then HA will be the head added or the energy added by the pump. Okay. And then we have this energy equation with turbine. So sa turbine, ang mahitabo binalira sa pump imbis nga muad siya og head, iyahang i-extract ang head. Iyang i-convert ang kana nga head into mechanical energy, and then i-convert na pod into electrical energy. So the energy at point 1 is equals to the energy at point 2 plus the head extracted plus the head lost from point 1 go to point 2. So this will be your energy equation. Okay, so the input power of turbine will be Q gamma HA, wherein again Q is the discharge, gamma is the head extract gamma is the weight density, He will be the head extracted or the energy used by the turbine or the energy extracted from the flowing liquid. Okay. So mao na imong energy again, mao na imong energy equation kung naa kay turbine sa. Okay, so we have here example number 1. Now in the figure shown, a fluid is flowing with 15 liters per second of water and the pressure from point 1 to point 2, wherein the pressure at point 1 is 100 kilopascal and the pressure at point 2 is 70 kilopascal. So the diameter at point 1 is 300 mm, while the diameter at point 2 is 100 mm. So uh, compute the head loss or the loss of head between points 1 and point 2. So uh, the total energy at point 1, let's say for example, is this one, and the total energy at point 2 is this one. So the vertical distance or the vertical distance between the energy at point 1 or the total energy at point 1 and the total energy at point 2 will be your head loss. So this will be your head loss. The distance from this point kutob ani nga horizontal line. Okay? Now, assuming that the center line of the pipe will be your datum line, so Z1 and Z2 should be equals to 0 since mao man siya imong datum line and uh, points 1 and point 2, point 1 and point 2 naigo sila mismo sa imong datum line. Okay? So, you convert the discharge into cubic meters per second. So, you have 0.015 cubic meters per second. Okay? So, you establish the equation. You establish your energy equation. So, you have the energy at point 1 is equals to the energy at point 2 plus the head loss. So, the energy at point 1 will be V1 squared over 2G plus the pressure head plus P1 over Z1 plus Z1 I mean equals to the velocity head at point 2 plus P2 over gamma plus Z2 plus the head loss from point 1 to point 2. You transfer this one nga rin diri sa imong right side. Okay? Wherein Z1 and Z2 again is equals to 0. So your problem now is the value of V1 and V2 since na naman kay value sa imong P1 o P2. So using the continuity equation, you have your Q or the discharge sa point 1 is equals to the discharge at point 2. So you have Q is equals to A1 V1 is equals to A2 V2. Okay, wherein your discharge is 0.015 is equals to the area at point 1, that is pi over 4 times 0.3 squared times V1, which is also equals to the area at point 2, that is pi over 4 times 0.1 squared V2. So you have V1 as 0.2122 meters per second, and then you have V2 as 1.91 meters per second. So substituting these values to the energy equation, you have 0.2122 squared over 2 times 9.81 plus the pressure head at point 1. So simply substitute. So 100 kilopascal divided by the density. So you have 9.81 kilonewton per cubic meter is equals to 1.91 squared over 2 times 9.81 plus 70 over 9.81 plus the head loss sa 1 to 2. So your head loss will be 2.874 meters. So that is the loss of head from point 1 to point 2. So maybe the reason for this head loss will be the sudden change of diameter. So gikan sa dako, nag-ana mo kagamay. So nakay head loss or maybe due to friction. Okay. So we have another example. From the figure shown, a 50 millimeter pipeline leads downhill from a reservoir and discharges it into air. So you have this as your reservoir with an elevation of 45.7 meters. So ang imuhang pipe nga 50 mm diameter ang abot ko to dito sa point B wherein the elevation of point B is equals to 0. If the loss of head between A and B is 44.2 meters, compute for the discharge. So what is unknown will be the discharge. So naan tayo head loss sa point point A go to point B. Then we have the pipe diameter, we have the elevation given, so the required will be the discharge. So you establish your energy equation from point A to point B. So you have your energy at point A is equals to the energy at point B plus the head loss. Okay? You add the head loss, ngari sa imuhang energy at point B. So mahimo nang equal imong system. So the energy at point A will be VA squared over 2G plus PA over gamma plus ZA while the energy at point B will be VB squared plus PB over gamma plus ZB. Okay? Now, you may notice nga ang value sa ato ang VA is equals to 0. Ano na 0 man? Since kining imuhang reservoir, the surface area of your reservoir is dako kayo sa compared to the area of your pipe, meaning pwede na to i-assume na ang kining tubig diri wa ni maglihok. Okay? So stagnant ni nga water diri ara ang tubig nga ni flow. So VA is equals to 0 and your PA is also equals to 0 since exposed man siya sa atmosphere and we neglected the atmospheric pressure. So PA is equals to 0 and also the pressure at point B is also equals to 0 and the elevation at point B is also equals to 0. So taking uh, the point B as your datum line or datum point. So mao na siya. So your your elevation head at point B is equals to 0 and the pressure head is also equals to 0 since we will assume that the pressure at point B, since this is already exposed to the atmosphere, the pressure here will be assumed as 0, neglecting the atmospheric pressure. Okay, you substitute the values. You have ZA as 45.7 minus the head loss from A to B, which is 44.2. So the only unknown here will be the velocity at point B. So the velocity at point B will be 5.425 meters per second. Okay? Using the formula for discharge, you have Q is equals to area times velocity, wherein the area is pi over 4 times 0.05 squared times 5.425. You will have a discharge of 10.65 liters per second. So this will be the discharge diri sa imuhang point B. Okay?